Hello, everyone. This is the second part of our demo video tutorial about syncing MySQL CDC data to Doris. I will introduce such a function to you and how to use it. We can see that I will mainly introduce the 2.3.4 version here. First of all, we need to find our source connector. Here we can see some introductions of the MySQL CDC connector. One of the engines it currently supports is our synchronization engine, and the second is that it supports the Flink engine. One of its features is that it only supports streaming reading, and then exactly once is to ensure the consistency of data and parallel reading. User-defined split can then also be supported. It does not support column projects. That is to say, it has no way to select which fields to read and which fields are not read if we want to synchronize only a few fields. During synchronization, we need to add transform to filter a field. We can't select fields in MySQL CDC source. These are some dependencies used as of the version of MySQL driver. I recommend 8.0.28. I tested it, and it is not possible to use 8.0.21. Then you can use 8.0.27 or 8.0.28. At present, the supported version of MySQL is 5.6, 5.7, or 8.0. 5.5 is not supported in version to 3.4 and to 3.5 and is expected to be supported in version to 3.6. The dev branch is now supported. If you want to synchronize MySQL 5.5 version, you can use the dev branch. Here are some steps to use it. First of all, we need to dp load and install the JDBC driver. Different engines will have different directories where the driver. If we use the Flink engine, the JDBC needs to be placed in the plugins directory under the setup installation directory. If the CTower engine is used, the driver needs to be in the lab directory of the CTower installation directory. This is a difference. I'm in here because I'm using the CTower engine, so you can take a look. My driver package is in the lab directory. You can see the contents of some price packages in the lab catalog. One is the driver package of my acquisition. There is also a package of dupe3 after AC under dupe C tono. And there is also a package of our transform. Then when we use MySQL, because MySQL synchronizes, it needs some higher permissions. Maybe sometimes we need to create a separate user to do CBC synchronization and synchronize the users according to the actual situation of everyone. The permissions he needs mainly include the select permission, the reload permission, the bus of sudo, and the republications. If we want to synchronize all the tables in all the libraries, that is ***, and then give it to the user. Finally, we need to refresh the permission policy. If you don't have these permissions, we will report an error when we synchronize, and it will prompt you that there is a problem with your permissions. The other is our MySQL. We need to open below MySQL. If our MySQL is turned on, you can check the query conditions through about. You can copy to your MySQL to query the returned value, if B2 if main mail explains 4. Then the following three are all on. If our database does not return these contents, then we need to modify the configuration file of MySQL to change some of these parameters. After the change, we need to restart our MySQL service, and then we will check it finally. Make sure that the values of these variables are consistent with those in the document. The other is that when we do synchronization, if we choose the way of first full and then incremental, it may happen during the full initialization phase, and it may take a long time to wait. There may be situations where a database connection times out. We can use these parameters to set the operation time of the database connection. Then, because the underlying use is DBM, there are many DBM parameters. You can look at the official documentation of DB and then set our version of DBM to be 1.6. You can refer to the parameters of DCMM to make some settings. Here are some mappings of our field types. This is mainly for developers. We can see the type of MySQL, then map it to the type in the other lane. Okay, I won't introduce it too much here. The next key point is the parameters of our connector. The first parameter is base-URL, which is mainly a connection address to our MySQL. The username and password will not be introduced, and then database enums can be filled in. It is a history dot. It is possible to specify the form of comma separation. But at present, my test is generally that a single library can run through more. I have not done the test. Table name is mainly used to specify the format of which data and which tables need to be synchronized. It is a format such as dbname plus table name. The following tableau msconfig. Its main function is to target some tables. And I want to make some separate special settings. For example, I have some tables, components, and I want to specify a parameter manually, similar to a virtual component. We can make a configuration through the tableau msconfig parameter. Then the startup model, which is mainly how to start when we start, is mainly divided into 4 ways. The first way is that it will do full initialization first. It is to synchronize all the historical data, the original table to the target side, then read the block automatically to do incremental synchronization. The second way is to start synchronization from the earliest block. He will go to the directory of MySQL block to find the earliest log that can be found. The file will be desynchronized from there. This synchronizes from the latest ratio that can be found, that the data after the moment you start will be synchronized. Data before startup is not synchronized. Okay. The last one is through the specified way. We can specify. There are some specified things in this, and we can specify a new one. That is to say, an offsite in the blog in my database is read from the offsite. Of course, I haven't used these. I don't know. I haven't tried it. We usually use this one. Or, yes, these 3 modes. Okay, you can also try it. Then stop model, which is mainly used to control when I read, when to stop. The default is never. This task will run all the time. And then it will be desynchronized in real time and synchronized to the downstream, and it will not stop. I haven't tried the other parameters here. Its function can be introduced to you. You can use it if it works. Or you can feed back the bugs to us, and we will try to fix them. This means that when it starts, it will record a point of the current bin log. Once recording the point when it starts, it is equivalent to a function of it will stop, and the task will be over. Offline batch reading of bin log by 1 click. This is the meaning of this parameter, and the parameters related to it below will not be described in detail here. Let's talk about this parameter, which is mainly used to control the full initialization phase. We know that when we read JDBC in Citanelli, it is actually reading of the data in fragments. The logic of fragmentation is different, and the connection will be different, like CDC. When it reads the full volume, it basically uses JDBC to read this parameter, which controls how many rows of data are split into a split. When I read the stock, this actually controls the efficiency of reading in parallel. Our suggestion is that if the default is the 8096, the reason why it is so small is that there is a parameter called exactly once, which is used in the full reading phase. Every split here it is 8096 lines, and then it will read the corresponding bin log, then take the data in the bin log and the data in the full phase split to do a deduplication. In the end, the effect it can achieve on the target side of writing that data the whole process of running the synchronization task throughout the whole phase. If this value of exactly once is set to false, it will achieve an effect that when I start, I record the point of a bin log, and then I do full synchronization. In the process of full synchronization, I will not read the bin log, then assume that I have to run for an hour in full synchronization, and when it is finished, and the incremental synchronization starts, it will read the data from the bin log an hour ago. The problem it brings is that you will find that the data on your target side will have a rollback just because JDBC may read the data of the last hour. The data read by JDBC is already ahead of schedule. It was an hour ago, after the blog point. For example, a field has been. Then by the time he actually reads and writes to the target, the value has undergone such a change from 1 to 10. The last value written to the destination with it is 10, and then when it starts the incremental phase, because it's going to read from an hour ago, you'll find that the value of the field will go back to 1. As the bin log continues to consume, it will change in the same order as before, and eventually back to 10. From 1 to 234. That is, it needs a process of tracking data. If we need high level of overall data consistency, then this parameter can be set to true. Once the parameter is set to true, the value must not be too large. It must be small. 8096, or set it according to the size of each row, because when it is set to true, this kind of filtration, it is completely deduplicated in the memory. If this value is set to be relatively large, it will cause so much data to be cached in the memory. Memory overflow will occur very likely. So we generally recommend that users do not open this parameter and just keep it by default. Then you can set this value a little bit larger. For example, set it to 100,000 or 200,000, then it can be significantly accelerated, or 500,000. The larger the value is, the more it can significantly accelerate the speed of the full phase reading. Of course, it is not the bigger the better. Generally, we suggest that if the amount of tens of millions of data or hundreds of millions of rows of data can be adjusted to 100,000. Of course, the premise is that the exactly once must be set to false. Otherwise, memory overflow will occur. Other parameters do not need to be changed, and the serve ID will automatically generated randomly by default, so you do not need to care about it. As for the time zone, you can set it to your needs. The following are some parameters you can ignore. Then the parameters of the connection pool should be useless. You don't have to worry about it, and you don't have to set it. Okay, here are some fragments. In the full phase 1 just mentioned, we are going to carry out fragmentation. These are some parameters of fragmentation I have already introduced in detail about the sharding in the last section, which is similar to the process of sharding here. So I won't repeat the introduction. The parameter of format is actually used to identify the data and in what format I output it downstream. By default, it is converted to other data format, that is signal row. Of course, if my downstream data is in Kafka format, and I want to directly output it in Debezium JSON format and then put it in Kafka to be consumed by the downstream Flink program, and do some real-time calculations. We can choose such a format. If we choose this format, it will read out the data and then output it to Debezium JSON. There are 3 fields in this format. The first is which topic is written in the downstream. Then here is some parameter configs of Debezium. We can refer to the Debezium official docs to configure the parameters. Here, I will not introduce it in detail. And then here are some common parameters. For source, here. The first one is result table name, which is mainly used to read the data of the source, what kind of downstream data sets I will output. Of course, in the scenario of multi-table sync, result table name is no longer a concept of a dataset. It is actually a match with source table name, which means that it can be used to form a connection. That is the connection between a pair of source and sync. It only plays the role of a connection. That is, the connection between the upstream and downstream. We should not regard it as a table and then transmit it to us. Especially in SQL transmission, we shouldn't select this table, but regard it as a connection. And then in the SQL transmission, the table we select should be the name of the table read in the source, not the result table name. Okay, pay attention to this point. The degree of parallelism is how many degrees of parallelism I need to open to read my data in the full phase. Okay, these are some common parameters of source. An example is given below. And we can see that's our task mode here. It is about a full initialization first, and then incremental synchronization. CDC task job mode is streaming, and to do a CDC task, we must configure all the checkpoints. Checkpoint is turned on by default. Then we can configure the interval duration and the timeout duration of the checkpoint. Here I define 2 tables. And I will take how to read the 2 tables as an example. Okay, this is multi-table sync. And then another example. It mainly introduces the use of the parameters of table name config. In these 2 tables, we suppose there is no component in table 2, and we want to do shard reading. The table has a large amount of data, and I want to read it in pieces. I can set its components in this way, which is similar to virtual components. When I set the field of the virtual component, it will shard and read according to the component field. This is a case of the MySQL CDC docs. Here I have written an example. I synchronize 2 tables. Because I synchronize these 2 tables to Doris, we are currently in version 2.3.4. I'm using a UNIIX model here. So it has 2 required components, so I won't introduce the scene without components like we just mentioned. If you can do that, welcome to contribute it to the community, like this demo video series. We hope that our users and contributors to build the program better together, instead of relying on my recording. Okay, welcome to contribute. We will make videos and articles to promote it. This is a MySQL CD and source that I configure. And then sync is similar to the JDBC I introduced in the last series. Here, I choose the 3-table reconstruction in the schema save mode. At the same time, we should pay attention to the CDC task. There is a special parameter in Doris sync called enable delete, which defaults to be false. It controls whether I should delete synchronously in Doris when the delete data occurs in the original table. The default is false. That means don't synchronize. I change it to synchronization. That is, when deleting data in the original table, delete the data in Doris, too, because the last series has introduced them. Okay, I'll take a look at these two tables at first. This is the first table, which is in the library. And there are some fields like this. Then the data volume is about 20,000 rows. And the maximum value of ID is 20,098. Then the other table's maximum ID value is 1000. Okay. And then, in Doris, these are two tables exist before. And I will delete them and rebuild them. Because I have made a name change in sync. It is to add a MySQL on the basis of the original table name as the indication of the target table. As you can see by this parameter, $table name represents the original table, followed by underscore MySQL. For example, my target table is generated by adding a circle suffix to the original table. Okay, then let's run this task now. Okay, and then we generate the config file. Submit the task. We can see that the task is running. Then let's look at the data in the database. This is the table in Doris. We can see the data in this table. It is already consistent with the data in the original table, and you can see that it is also 20,098. And then the other table should be the same. You can see that it is also 1000. Now we add 2 lines in the original table, and then we can see that the 2 rows of data have been synchronized to the target table. And then I can modify the data, and I delete this line of data. Okay, yes. See, this line has been changed to 1. And then the line 20,097 has been deleted. Okay. This is about how to sync data from MySQL CDC to Doris. If I use another way now, that is, the startup mode is changed to synchronize only the incremental data instead of the full data. In this case, what will happen? We can take a look. Okay. Startup mode. In this scenario, it will delete the target table and rebuild it after deletion. But the historical data in the original table will not be synchronized. Only when changes occur in the original table will the changes be synchronized to the target table. We can stop this task first. You can put this task together again. When start up this task, we can go to the target table to check. This is our target table. You can see that there is no data in the table at this time, and the table is deleted and rebuilt. At this time, I modify this field into 1, and then I'm going to add a field. OK. Now we look at the target table. We can see that the two rows of data have been synchronized. And the field has been changed to 1. And at the same time, a new data has been added. Other modes will not be introduced in detail. If you're interested in this, you can try it by yourself. Alright, this is all this video about. If you have any question, you can submit issues on GitHub or discuss it in SLCK, or send an email to our mailing list. Of course, you are also welcome to contribute a video like this one, describing a usage scenario and introducing the usage documentation, and then make a demo in video TP show how it runs and its effect. Okay, that's all for today. Thank you all.